Hello everyone, back with another devlog with a little equilibrium simulation software. A lot of the changes I made this time were internal again. I reworked all of the data to use decimal. So now all the internal calculations it does with this decimal object, which makes it more precise. It doesn't lose precision because floating points really quickly lose precision as you go too small or too high. So we fixed that. And I reworked the scaling on this. Oh, it's still broken. Whatever. I'll fix it later. Either way, this should be fixed. Let me try to fix it again. Where would it be? Where's this? This is Q? No. On axis, that'd be right here. I think this should be this should be 2. Yeah. Much better. Okay. This needs to be moved a little bit to the left. Let's fix that really quick. Just where's y-axis label used? Just knock this down to like 5, and that should solve the issue. Still a bit too much. Maybe like 3, maybe 2. We're just moving it to the side a little bit. Too much. I was right with 3. Good enough for government work. I might work on that later, but it's fine for now. But anyway, now, for example, if you, for example, in this case, if we bring the temperature up, it brings the Ka constant way down. If you look at the size, you'll notice they go into scientific notation when accurate. When appropriate, it's still at plus 0, 0 because of this little spike right here, but as soon as that goes off the axis, it'll rescale itself to be all proper. And, yeah. So now it's dropping down to the proper scaling. And there you go. And if we cool or heat it up even further, it drops even farther. It goes pretty far down to, pretty low. It goes pretty low. Here's -5. We get diminishing returns as we heat it, but you get my point, right? And the scale adjusts accordingly. And oh, that's actually okay. And you'll notice here that this graph on the top here also does that. So you see when it gets really small, it rounds, or when it gets really small, it goes into scientific notation. I also fixed some bugs where this, when it was at extreme values, like if one of the reactants or products hit 0, the reactant would start going down because the reverse rate was still technically negative, but we were clamping it the wrong way. So I fixed the clamping there. Also, I did a fun little feature when you cool it down. Since the delta H here is negative, if you cool it down, it actually increases the reaction quotient, but it's a logarithmic or exponential scale, so it increases it real fast. So it's increasing. This is already fully reacted, if you notice. If we increase it even further, at some point it goes into scientific notation. If we keep going, all the way down to absolute 0, it does not like that. It tells us to stop. I don't think it's actually at absolute 0. I think it's at some temperature past which just stops being able to represent the numbers properly. It just politely asks us to stop. I just put this in as a joke. I don't know if I'll keep it. But, yeah. That's all I've got for today. The next thing I'm going to work on is probably making the movement in the panel speed up and slow down according to temperature. Yeah, and that's all I have for today. Thank you so much.